We're barely into 2025 and there's already a big AI shakeup with DeepSeek. So what should companies do when AI innovation continues to accelerate? And what can we expect for the rest of the year? We're going to try to catch up and look ahead on this episode of Today in Tech. Hi, everybody. Welcome to Today in Tech. I'm Keith Shaw. Joining me on the show today is Debo Dutta. He is the Chief AI Officer at Nutanix. Welcome, Debo.
Thank you, Keith.
All right, so I think when we initially planned this episode, we were talking about predictions for 2025, and this was way back in December, and all of a sudden now we're in January, and bam, like all of this news is hitting. So you did actually write out a couple of predictions for me about what the trends for 2025 are going to be, but then with the DeepSeek news that really kind of roiled the stock markets and all of this stuff about efficiency and open source and things like that. So we're going to jump right into that as well, but I want to talk about two of the predictions that you made that seemingly it's already kind of come to pass with a lot of this news. So the first one was that we're going to be getting closer to AGI in 2025 via reasoning models, and at the time you had mentioned OpenAI o1 and its competition from Meta, Llama, and Alibaba, and now we've got DeepSeek. So this is going to give AI models significantly more capabilities than today. So can you briefly explain what a reasoning model is doing and why that's different from what people have been using so far, and then we're going to get into some of the other stuff that DeepSeek came out with.
Yeah. So let's talk about reasoning models in general, because DeepSeek is a type of reasoning model. So in traditional large language models, the model predicts based on its representation. So essentially, a simple way of saying this is that it's a stochastic parrot that is seemingly producing very useful information. But in reasoning models, so reasoning is like how our brains think, right? We look at something and then we try to reason, if then else, right? We try to think through. And so the reasoning model actually adds that kind of reasoning steps in addition to generation, the typical generation that you have in large language models. When you combine that with you get very accurate and very powerful model that can be used for very complex tasks, like solving a math problem or a physics problem.
Yeah, and so the reasoning models that are coming out now, and all of the new stuff, is that just going to change the way of what we think AI can accomplish? Do a majority of the end users? It feels like that a majority of the end users that are using this stuff now are still looking in that search engine world of like, question answer, question answer, question answer. And then the reasoning models, so to speak, would only be used by scientists or researchers or medical stuff, things like that, and that the mass majority probably won't be using that. Or are we going to start seeing more of those types of questions and answers from the average end user?
So that's a very good question, Keith. So let me just kind of split it into two parts, right? So there is this class of use cases that seems to work fine with our regular non-reasoning type models, because non-reasoning type models over time also have gotten very powerful, right? And you can see the open source versions like Llamas of the world, right? But so for some use cases, non-reasoning will be good. But for some complex use cases, for example, if you want to use an LLM for doing audits on documents, where you may have to augment it with human question answering, I think the reasoning models over there will shine in the more advanced use cases in general.
Okay, and so then how does DeepSeek kind of shake all this up in the model with the model space, and not the open source part of it, because we're going to get to that next, but within the reasoning model, did they accomplish anything different here that has got people all worried?
So DeepSeek as a model is a class of reasoning models. So there's OpenAI has that, Google has a reasoning model. So it's one of those models. And I think it's done well in a bunch of benchmarks. It's almost as good as OpenAI's reasoning model in certain benchmarks. And that's the exciting part. And the other exciting part is their claim that it was done with much less resources.
Right. And so, yeah, that's what was freaking everybody out, was that the cost to produce the training model for this, right, or the training on the model was 6.5 million versus hundreds and hundreds of millions versus some of these other models, correct?
Yeah, so I can't comment on that one because we haven't obviously tried to do that same thing.
Yeah.
So, but yeah, that's the most exciting part of DeepSeek to the world. But to us, to us, the DeepSeek is just another reasoning model, and we expected last year when we made the predictions that reasoning models will take over.
Yeah.
In terms of mind share, and will be used by the enterprise to solve harder problems.
Yeah. So what do you think companies should do if they're all of a sudden they were like, well, we made a decision, we're going to use 2 or 3 different models, and now they've got to add in another one, correct? Or this also seems like this is the just the beginning of potentially other models that will come out, especially if the math works out, right?
Yeah, so that's a very interesting question, because this space is moving so fast that my recommendation to the enterprise market is that we should keep an eye on these reasoning models and be agile about incorporating them. Because one thing to note is, even though these models are different, they can still be used in the same way by our enterprise AI apps.
Right.
So things don't change on top of the layer.
Right.
So think of this as you're driving a Toyota and now you have a Porsche engine.
Still
you don't
driving
need
the
to
Toyota.
stop driving your Toyota.
All right, so I want to get into the second prediction here. You were talking about generative AI leadership is open, small, and global. While we see a lot of open permissible models that can do so as well, if not better than closed models, models will also get compressed by learning from bigger and powerful models. So I know that a lot of companies do get nervous when they hear about the words open and global. And it feels like, why are these models, potentially better than some of the either bigger models that are out there, and then the whole open source thing. Because especially when you talk about security and privacy, I think a lot of people get nervous in the business space about making sure their data is protected. And I think it's still a little early, because I'm not seeing, all of the hype I'm seeing about DeepSeek, no one's really talking yet to the enterprise companies, because they're concerned about where the data is going and then what they do with that data, for example, right?
Yeah, so I think we can split this question into 2 parts.
Okay,
right?
that you're
One
allowed.
is open source model, and then how do you connect data to it?
I'm sorry, can you just say that again? Could you say that again as I interrupted you?
How an enterprise can connect their data to it, because that's very important for the enterprise. So let's think about models. Models are trained on a large corpus of data. Usually, a model provider, they don't disclose exactly the corpus of data that they trained on.
Yeah.
So the base model is always going to be, it'll have very similar properties compared to an open source model. The open source model is, the difference is that the open source model, actually, the code is out there in the open, and also the license is permissible. So that's your base model. But what enterprises need to do with the base model is that they need to kind of connect the data to it. And when you connect your data, you have to be very careful and put the right guardrails, and you have to choose the right way or your right infrastructure, so that you are not giving away your intellectual property, like prompts, and your corporate data, to a third party who you do not trust.
Right.
And that depends on the type of how sensitive the customer is. So I think there are 2 aspects to it. So I think open models, I wouldn't say open source, because let's just call it open models. Open permissible models are actually great for the industry, because they also kind of help build a community of model builders who rapidly learn from each other and advance this, which would be hard to do if there were no open source models.
Right. So, like, what if a company is looking at this model? Then, do they hold back because of some of the privacy and data questions that might come up, or is it more just about making sure that they have the guardrails when they add in their own data? I would still be wary about where that data is going just on the open side too, right?
Mm-hmm. So I'll tell you, my recommendation would be to kind of tell the enterprise customer to do their due diligence right.
Yeah.
And that implies both an engineering due diligence as well as the legal and compliance due diligence. So for certain use cases, unless the model allows them to generate a certain type of content, they should not be using it. For example, if they are worried about indemnification, they have to look at the model and see whether the model has those provisions.
Right.
So it all depends on the use case and what they want to do with the particular model in question, which is why then the center of excellence for every enterprise has to be a collaboration between the technical teams as well as the legal and compliance teams.
Okay. I want to get on to the one of the third predictions that you had, and you can tell me whether or not this has been kind of come true or not yet, or is it still going to be down the road? But you talk about inference scaling or scaling computation during inference time will dramatically increase the cost of AI inference. Enterprises will need to revisit their infrastructure and power investments due to this new technology trend. So there is a difference between the cost involved in training a model and then the cost when you move into inference, when you start asking it questions and getting answers. It feels like you're saying that cost is going to go up, and that seems like to be another big red flag for a lot of companies, because even in the past couple of years, they're seeing how much money they're spending on a lot of these projects, and they want sort of the scaling to take over, right, and start bringing the cost down. So I think they would be really worried if all of a sudden people are saying, well, the costs are going to go up. Is that still an issue here, with especially since DeepSeek now is claiming that they were able to build this training model at a lower cost, but we still don't know what that means for inference, right?
Yeah. So instead of focusing on DeepSeek, I'll talk about general inference scaling as a trend.
That's fine.
Let's double click on what is inference time scaling. So it's basically the extra compute that you have to do while doing the inference, which means generating the tokens. You have to do some extra compute. For example, you may want to call an external verifier to see if the generated tokens were right. For example, if you're trying to prove something. So that verifier is the extra compute that needs to be done in an inference or some kind of a search. So this is extra compute, and if you want to really improve the accuracy, there's a school of thought that inference time compute will bump the accuracy significantly more than it is today for complex tasks. And that's why it is a trend, and which is why you see vendors, charging more for different tiers of their models. And my prediction is that it's an order of magnitude more computations at a minimum.
Is that also gonna then place higher demand for power generation? So we're going to continue to see a lot of the news around, how much it costs to run a lot of these data centers and the trading off of answers versus power that we've been seeing with some of the early generative AI stuff.
So maybe, and I'll just say maybe because it also depends on how you run the inference. So if you run inference time compute with the traditional architectures, yes, probably it will generate more power because it's more compute. But in addition, people are looking at alternative architectures. That's actually in the research arena already, right? How do you bring down power in general for inference? So we'll see a lot of development in the space of inference because of new models, reasoning models, inference time compute as an aggregate.
Yeah. Okay. Number 4 on your list is that new technology and architecture is going to emerge that will fuel next generation models in multi-agent systems, and we're going to get into the agent stuff too on your next prediction. But there was something interesting in the prediction that I want you to explain a little bit. So companies you say are going to face a memory wall, and in-memory compute is going to get popular. So explain what you mean by the memory wall and why you can't just add more memory to the system, the way that people traditionally think about it with computing. So talk about what this wall that companies are going to be hitting.
So, I mean, I used to love assembling my gaming PCs at one point in time. So,
good for you.
What you could do is, you could buy a server or a PC and then just put in memory cards.
Right.
And keep expanding as you needed it. But remember, what happens over there is that the memory is still external to the CPU or the processor complex, right? In those days, and the GPU. So the GPU, CPU, memory, they are all different components, and there are different buses that connect each other, and those are the bottlenecks. So think about the highways get congested very easily with cars being data, right?
Yeah.
So the newer architectures, what they do is they have memory, CPU cores, and accelerator cores all on the same silicon complex with very fast interconnects. And that means basically from a 2-lane highway, you've gone to a 100-lane highway. And now suddenly computations get faster, especially when they have to go back and forth between processing elements and memory, which is what happens in large language model inference and so on and so forth.
So these new architectures are going to be needed because of this memory wall that they're hitting, right?
Yes, because large language models are memory bound. As you go larger, the memory, the model parameters have to fit into memory.
Okay, and so are companies going to have to then basically what we call rip and replace to get more memory, or can they just be added on to existing infrastructures? Which again, maybe is my question is like, can you just add more memory? But it sounds like you can't.
So for certain of those applications and use cases, you can't. You have to use different, processing components in your overall system architecture. But there are many other ways to, deal with the problem. You can deal with the problem by creating smaller models that fit into smaller memory.
Yeah.
You can create more efficient models by doing quantization. You can do more system level tricks by writing using a better compiler trick. So there are many ways to fit models into existing architectures already.
Okay.
Learning from a big model and creating a small model.
Yeah.
So that's one way to do it. But for certain use cases, you really want the biggest memory and you want the fastest compute. I think that's why people are looking at newer architectures all the time.
All right. So we've been talking a lot on this show recently about AI agents. We've probably done about 3 or 4 different episodes around that topic and that innovation. One of your predictions is that multi-agent AI or systems of cooperating agents are going to basically take center stage and will involve a collection of AI agents working cooperatively and will need new people, processes, and technology to enable this in the enterprise. And that you're also seeing that agents will also negotiate with other agents. Again, so my question for you would be, as companies are looking at this, should they look more towards the reasoning models as their big trend for 25, or is it the multi-agents and the AI agents and getting some pilots off the ground there and then worrying about the reasoning models later, or can they do both? Is there a world where they can do both at the same time?
So I believe that they can do both for the following reason.
I knew you were going to say that. That's why I already predicted your answer.
No, I'll give you a quick reason why I believe that, because I'm trying to be a reasoning model now.
Okay, there you go.
So an agent is basically a Lego block to get something done, right? So it has some state, it has some memory, and it has an ability to use a large language model to think, and then it has some way to kind of do some function calling and some APIs and all that, right? To basically do some actuations. So essentially, that's what an agent is. So it's orthogonal to the model because you could put fancier models as part of your agent workflow.
Yeah. So do companies have to, like, are they going to get benefits out of these AI agents from the recent? I mean, it feels like they would get benefits from the
Yes.
reasoning models, but they don't have to. They could still use older models, right? For some of their initial agents, or at this
it
point they'll
depends.
just be like, hey, the new models are out there. We're just going to use the newest for the project.
So assuming that the new models get better and can be shrunk effectively, you could use the new models. I'll give you a concrete example. A factory of agents for the software developer would include an agent to do code review, to do unit testing, to do code explainability, and do code searching agents, and also code generation agents. And maybe in the advanced stages, we may have even automatic bug fixing agents for simple errors, right? So all these agents are a family of agents which could use better and better models for that can understand code.
If a company came in and said that they hadn't done anything with the earlier models of generative AI, and they said to you, all right, Debo, we want to just kind of start with an agent project. We don't want to do all this other chatbot stuff or the earlier stuff, or we just want to jump right in. Can they, or do you have to have a baseline of, hey, listen, you at least got to get through some of the early stuff. It's like if I wanted to drive a truck, I would have to learn how to drive a car first, right? Like I can't just go and start learning without learning the basics, right?
Yes. So my recommendation to an enterprise person would be, let's get your infrastructure right and ensure that you can run models first.
Yep.
And simple chatbots first, and then jump into agents. So it would be crawl, walk, run.
Okay. All right. So so you're not like you're not getting behind the wheel of an 18-wheeler without actually learning how to drive a regular car first, right?
Personally.
All right. Yeah, I feel a little bit safer now. All right. So with a lot of this stuff going on, I think I imagine that companies are going, especially now, especially with what happened with DeepSeek, everyone's going, we just barely got started with a lot of these technologies. I know that enterprises and other big companies, for example, they take a year to usually get a project going because of all of the different processes they have, and you get legal involved and you get marketing and all the other different groups. When they're looking at the world and they're seeing all of this news, can they separate the hype from, the reality, or are they basically saying, well, this is the new reality, and we have to expect that things are going to change on a weekly, a monthly, if not weekly basis, right? So, what advice would you give for a lot of companies that are going through this, going, you're asking me to change my infrastructure, you're asking me to change, come up with agent type projects, you're looking at reasoning models, we barely got our data cleaned up, or we just finished our data transformation or digital transformation project, or are you not seeing that out there? Are companies keeping up with all of these things?
So that's a very packed.
I throw a lot into that question.
Yeah, so that's like multiple questions, but I can try to answer one by one. So for example, for an enterprise who's trying to accelerate the digital transformation, their North Star could be to have a factory of agents that drive efficiency for the company. That could be the North Star. But there's a journey to get to the North Star. In order to get to the journey, they have to first understand how to use basic chatbots and models. Mm-hmm. I mean, if they are developing it, right? So if they are themselves developing it, then there's one road, which is decide your infrastructure, learn how to use models, define your business KPIs, and do rapid POCs to figure out if you can get a value. For example, in software development, can you get to 25% efficiency? Or if you want to do customer service, can you get to 15% efficiency? So define your business KPIs, and then POCs and evaluate that you are already out there. You can get value out of it. Now, once you deploy this, you can then start thinking about, okay, so this was just one use case. What if I have 20 use cases across 3 departments in my organization? And for each use case, I may need to do some automation.
Right.
That's when you move to agents. So agents are useful when you have to also do some automation and do some decision making. And the decision making can be broken down into whether you want to use a simple model or a reasoning model based on the exact use case.
Okay. Yeah. So what's the big takeaway message that you would have for a company that's coming up to you and going, okay, what out of all of these different trends should I focus the most on? Like maybe they don't have time to pick, to do all 5 of these things, or, what should they prioritize for this year? And then maybe they can hold off on some other things.
Yes, I would say for this year, the best thing to do for a company who's not done, let's say they have not done any AI, is to get your infrastructure right, infrastructure strategy, and a basic 3 use cases within the company, and do a good high quality POC, either them by themselves or with a partner or with a system integrator.
Okay.
And make sure that they're deployed to some level of production and they get some KPI. Sometimes you have to run slow to move fast.
Yeah.
And once you do, while these POCs are doing, let's define the North Star of, going to 10 plus use cases. And some of them will need agents, some of them would not, and have a way to get there. So that way, while their POCs are going on and the upper management sees the value in actually using AI, they have the entire technology strategy straight. So do it in parallel.
Right.
Get value and build out the infrastructure strategy and the data governance strategy, because the value of AI is when you combine agents and models and to data, to your proprietary data. So that's going to take some time for people who haven't started that journey.
And are you seeing anybody that's still waiting on the sidelines, or are you hearing basically that companies have at least something going on with AI?
I think a majority of the companies have something going on.
And you wouldn't recommend just waiting out another year or so, right? Like that seems like a bad idea.
Personally, I wouldn't.
Yeah. Okay. All right. Debo Dutta, again, thanks again for being on the show. This is some great stuff as we continue to watch the journey of generative AI.
Thank you very much for the opportunity.
All right. That's all the time we have for today's episode. Be sure to like the video, subscribe to the channel, add any thoughts you have below. Join us every week for new episodes of Today in Tech. I'm Keith Shaw. Thanks for watching.